Ciao, friends. That's a good way to start. Hi, guys. I'm Alberto Ferrari, and we are here to talk about time intelligence in DAX. The idea is that you should already use Power BI. You should have some basic knowledge about Power BI, and I want to talk about the best practices, so how you could build time intelligence, and then we'll see some DAX code and we play with it a bit. Hopefully, you will be able to help me in writing code. If not, it's just a one-way session where I'm just talking. First of all, what is time intelligence? Well, time intelligence is any calculation regarding time. In business intelligence, we like to find complex names for simple topics, but any calculation like a year to date, so a cumulative total that starts from the beginning of the year and then grows through the year, or comparing the current year with the previous year, or the current year to date against the previous year to date. All these calculations is what we call time intelligence. So any calculation that has to do with time. And it's important to know how to solve time intelligence calculation, because I don't know about your customers, but with my customers, time intelligence is where their creativity reaches the highest level. They always want to compute complex comparisons year over year, like a week comparison or comparison using working days or stuff like that. And it's hard to solve those problems if you don't have a clear picture about how to create time intelligence calculations. First of all, if you need to do any sort of time intelligence calculation, you need to have a date table. The model we are going to use is a variation of Contoso, a very simple model. I guess you see my screen. Just nod with your hand to tell me that everything is working. Cool. And can you read at that size, or should I zoom in?
I think a bit. It should be bigger a bit.
That way, maybe. Okay. We have customer product, only 2 dimensions in this model, and then sales and purchases, which are 2 fact table containing sales. Sales happens online. So in the sales table, we know who the customer is. Oh, that is purchase. No, sales is sales and purchase is stuff that we purchase. It's just 2 fact table containing some data. And the data inside is not interesting at all. What matters is that we have 2 fact tables with several dates. If you look here, we have in sales, we have delivery date and order date, which are 2 dates. Whereas in purchases, we have, again, delivery date, order date, 2 dates there. And there's no date table here. So the first thing to know about time intelligence is that time intelligence works somewhat by magic, and it works in the wrong way. If we look at the sales table, it's very simple. It only contains a product, the quantity, the net price, and then we have the 2 dates, delivery date and order date. Please note that we do not have a year, a quarter, a month. These columns are not part of the sales table. And there's no date table anywhere. So I'm messing up with the zoom. Okay, we only have customer, product, purchase, and sales. There's no date dimension right now. However, if I just take the order date and I drop it in my matrix, you see that I can slice by year, and then I can slice by quarter, and finally I can slice by month and by individual days in the month. The thing is, these columns are nowhere in the model. So the first interesting question is, where do they come from? How comes that Power BI can let me slice and see January, February, and March if sales does not contain those columns? The answer is that Power BI generates automatically date dimensions if no date dimension is present in my model. Unfortunately, it does it the wrong way. So it's good to see what it does to avoid the problem in your models, because the model does not contain any date dimension anywhere. But actually, if a date column is not linked to a dimension that contains a date as a key, then Power BI automatically generates date dimensions, 1 for each date in the model. You cannot see them in the diagram view because Power BI is shy and it doesn't want to show you what it is doing. But if you just launch DAX Studio or Tabular Editor or any other tool that queries the metadata of the model and let you see the content of the model, you see that we actually have several date dimensions which are hidden. And these dimensions contain, let's go for this one, a hierarchy containing the year, the quarter, the month, and finally the day, which are exactly the columns that you see in the matrix. The problem with the approach of Power BI is that it creates one dimension for each date. You see that we have 1, 2, 3, 4, 5 different dimensions because we have 5 date columns in the model. So despite working nicely, you can use those columns to slide the sales amount. If I want to show, for example, the sales amount and the purchase amount in the same report, I'm not be able to do that because the column, the year that filters the sales amount has no way to filter the purchase amount too, because we have one table for the sales, for the order date in sales, one table for the purchase date for the purchase data in purchases, and there are no ways you can merge these two in one table only. So it shows this as the biggest limitation. The second, and to me, quite important limitation is that you have no control over these tables. You cannot change them, you cannot modify them. If for whatever reason you don't like a QTR1 and you just want Q1, there are no ways you can configure these tables and change them for you. On the other hand, these tables are needed if you want to use the, how do they call them, the quick measures. Quick measures are based on these date dimensions, and that is, to me, a very good reason never to use quick measures. Not only their code is suboptimal, but they require you to use a date dimension built by Power BI, which is mostly the wrong dimension. So the best gift that you can do to yourself regarding this feature is to disable the automatic creation of dates by Power BI. So it's quite simple. You just go to File, Options, and among the many options in the data load part, there is this Auto Date Time. You just uncheck it, and while you are there, you can also go in Global Data Load and disable also Auto Date Time for new files, so that whenever you create a new file, Auto Date Time will never be active again. Do that just because it was a huge fight obtaining that flag, so that you will never have to work with Auto Date Time again. This feature that of automatically creating the date dimension is what Microsoft calls Auto Date Time. As soon as we disable Auto Date Time, if you look at DAX Studio, you see that now we have only the 4 tables that are part of the model. So Power BI is no longer messing up with our data model, but we can no longer slice by date. We can by year, we can slice by individual dates. We no longer have the option of slicing by quarter, month, and so on. So we need a date dimension. There are multiple ways you can create a date dimension. I'm going to use a very simple one. So we start writing some code, a very simple piece of DAX code to automatically create your date dimension. There are other ways you can do that. You can use Bravo. You can load it from the data warehouse. You can build the data table the way you like. I like DAX, so I like to write that in DAX. So you can create a date dimension using a function that is Calendar Auto. Calendar Auto is a magic function that scans your model and builds a date dimension that is able to reference any date column in the entire model. If you just launch it, it generates a table that starts in 1910 and it ends in, let's sort descending. No way again. It ends in 2009. The data in this model probably ends in 2009. So it spans like 100 years of data, which is unfortunate because if we look at order date, for example, we start having sales in 2007. So there seems to be no need to have 1910 as one of the years in the date dimension. The thing is, Calendar Auto scans any date column in the entire model. And among the many columns, it also finds the birth date. And in the birth date, we do have customers which were born in 1910. Let me sort it ascending. There are a lot of blanks, but at some point, we probably have somebody who was born in 1910. And that's the reason why we create Power BI created such a large data dimension. The size of the data dimension is important. The larger the dimension, the slower any calculation will be. So we don't want to have 36,000 rows in the data dimension. We want to reduce the size to a more reasonable size. And any idea how I can do that? That's the first question, and either you answer or I will go forward. 3,
Any
2.
ideas?
I'm looking at you, blonde girl.
No, I was just thinking that's how we build it in the project, where we are building like each column separately. But I know that there is a simple function which is like building everything. But right now, this is something which I don't remember.
Okay, no problem. You can just filter. We can filter calendar auto, and we say, well, I want the date to be greater or equal, for example, the minimum of sales order date. If I do that, what I obtain is a completely different table that is much smaller. Let me sort it ascending. Now you see it starts. Okay, it wasn't long assuming. On the 2nd of January 2007. And here is the first problem. It is super important that your date dimension starts on the 1st of January and it ends on the 31st of December. All the dates in the year need to be present for any year that is referenced in your fact table. Starting on the 2nd of January, as it's happening here, is not a good option. You will not see any error, you will not see any specific problem, but time intelligence will not work. You are in danger because some calculation might be wrong, and it's the kind of wrong that will drive you crazy because they are very hard to spot as issues. And the best thing that you can do is just build your data dimension that contains all the dates. So instead of filtering the date, we can just filter the year. And by using year and year here, what we obtain is all the dates where the year of the date is greater or equal than the first year, so that the 1st of January will be included in the set. And it's enough to hit enter. And now you see that my date starts on the 1st of January 2007, and it ends on the 31st of December 2009. So this is a good date dimension, or at least it's the key of the date dimension. It's still missing all the columns that are needed, like the year, the quarter, and all the other columns. But we have DAX, so we can just add a few columns to this table. We add the year, and we just extract the year of the date. And now you see the table contains both the date and the year. And in a similar way, I can add other columns that I need for my model. We need the month, so we format the date as a long month. And then we need the month number, which is just the month of the data. We have the quarter, so we add the quarter, where we use Q and quarter. We have the function that does it of the date, and so on. In a similar way, you can generate all the columns that are needed for your model. So we end up with a table containing the date, the year, the month number, the quarter, and all the relevant columns. Finally, we need to build a set of relationships. So we just place the date here, and we create a relationship between order date and date. And now that I have done it, I can go back, and instead of slicing by order date, I can just use columns from my date dimension, and I can slice by year, place it on the rows, and I see 2007 sales amount. The purchase amount is still wrong, but now that we have control over the model, it's enough to link also the order date of purchases with date. And now my date dimension is filtering both sales amount and purchase amount in a reasonable way. Then we can add the month. And for example, we extend 2008, and the result is not really sexy. You see, it shows April, August, December, February, January, because it's sorting alphabetically. And alphabetical sort, of course, is the wrong sorting for the month. But we do have a very quick solution. That is, I'm still looking at you, blonde girl.
Sort by month number.
Sort by month number. I love it. So we go on the month and we sort it by month number, and it works. So it's pretty simple. I can now slice the sales amount. I can slice the purchase amount. What if I want to slice not by order data? You see, I have in sales, I have the order data that links to the data. In purchases, I have the order data. What if I want to slice by delivery data? So I don't want to see the amount order, I want to see the amount delivered. Well, right now, the relationship is between data and order data. So if I try to create a relationship between delivery date and data, that works. But as you see, maybe larger, this relationship is dotted, whereas the other one is solid. It is dotted because it's a disabled relationship. If you double click on it, the make this relationship active is unchecked. And if you try to check it, it says, I'm sorry, pal, you cannot create a relationship because otherwise the model would become ambiguous. The engine would not know how to move a filter between date and sales. It doesn't know whether it is better to use the relationship with order date or the relationship with delivery date. And you would have to specify every time which relationship you want to activate in order to avoid that, even because there are a lot of filters that are moved automatically. Power BI forces you to have only one active relationship between any two tables. And in this case, the relationship is kept inactive. So if I want to see not the sales amount, but the delivery amount, I have a couple of options. I'm going to explore both of them. You just need to tell me which one you like more. If you were in this situation, what would you do?
I would create another delivery date dimension, just because you can you can create both relationships and then use relationship. But this is like, at least in my opinion, how I feel in the project. When client is approaching something, like using something, then you have to define in measure that it's working over this date instead of the other date. So I would create separate dimension and then connect it with delivery date.
Okay, what I normally, that's a very common option. And what I always tell to my students is when you create your first second date table, you're just opening the doors of hell and you are ready to jump into it because it never stops at the second date table. You end up creating 2, 3, 4, 5, 10 different date dimensions because there are so many dates. However, let's go for that version first. We can create a new table. Let's call it delivery date. We don't want sales order date. We want to use sales delivery date. The remaining part of the code is the same. And now that we have a delivery date dimension, we get rid of this relationship and we build a new relationship between delivery date and date. Ambiguity is no longer an issue because now delivery date filters sales and data filters sales. And if I want to slice by year, I can use not the month and the year from the order data. I can, for example, use the year from the delivery date. And now I'm looking at the different years, the sales amount and the purchase amount. And here I face the first problem. The delivery date filters the sales amount, but not the purchase amount. So the question for you is, should I create a relationship also between delivery date in purchase and delivery data in the delivery data or not?
It depends on how client wants to analyze the data, because this is one of the things. If client wants to analyze both data over delivery date because it means something for them, then you create a relationship with both. That's how I think.
Otherwise, no. That makes sense. In this case, we are in a very lucky example because we have purchases and sales. In a real world example, you're likely to have like 5, 10 different dates, no, maybe 5 dates in sales and 5 different dates in purchases and maybe some other dimension. So deciding which table filters what is kind of a nightmare. Not only deciding from the modeling point of view, but also for the users to remember which date filters what in order to obtain meaningful results. And that's the first problem. The second problem is that users can very quickly build reports like this one. Let's get rid of purchase amount for now. And take, for example, the delivery year. Let's place it on the columns. It makes it more readable. And the order date on the rows. And you build a report like this. That makes sense. It shows that you placed some orders in 2007, part of which has been delivered in 2008. Then you placed you received orders in 2008, part of which has been delivered in 2009, and you received order in 2009, and none of which has been delivered later. This report is nice because it provides some information, but it's just horrible because if you show this report to anybody, the first question would be, I'm sorry, but what's the meaning of this 2007 and what's the meaning of, what do they mean? Is this the same as this, or what do you mean by that? So if you ever go for such a solution where you have multiple dates in your model, then at least you need to pay attention, for example, in delivery data for the year or any column that is needed to write something like delivered in and then the year, so that the same report shows in a better way the year, the date, the order, and then delivered in 2007. This report is much easier to read and analyze because the user doesn't have to ask to anybody. It knows that this is delivered in, and delivered in. This solution, having multiple dates, makes sense. So there are some scenarios where it makes sense to have such a solution, but there are not so many. There is just a small number of scenarios where it really makes sense. Specifically, it makes sense if you want to build a report that contains the year on the rows and a different year on the column. So the two dimensions together in the same report. And it makes sense if between the order date and the delivery date, a lot of things happen. In the very specific case of Contoso, Contoso receives orders and they are always delivered in a matter of a couple of weeks. So if they ever build such a report, they will only see the data in the diagonal, and most of the report will be empty because there is no information. There is no order received in 2007 and delivered in 2009. Whereas if you build houses or ships or airplanes that take years to build, then of course such a report might make sense. However, as I said, there are several issues. The first one is that you never stop at 2. You end up building 3, 4, 5, 6 different date dimensions, which is a nightmare. And defining the lattice of relationship, again, that becomes quite complex, up to the point that from the point of users, it's harder to use the models. So to be honest, whenever users ask me, hey, I would like to build a second date dimension, my first answer is, I'm sorry, Power BI does not support having multiple date dimensions, so you can't. And if it works, so they trust me, we just use one date dimension. If it doesn't, because they read somewhere that they can create multiple date dimensions, then we start a fight. And I have to discuss about how important it is to have only one date dimension. Moreover, the last detail is that you cannot, with this model, create a simple report that contains the year. Let's get rid of the delivery year, the sales amount, and in a column here, the delivered amount. So I want to have in the same report the amount ordered and the amount delivered. If you have two different dimensions, it's kind of a nightmare writing the DAX code that computes the two calculations at the same time. You can do that. You can create quite a complex, not complex, but strange piece of DAX code. You can use delivered amount, and you can just calculate sales amount, And you can use 3 tags, for example, 3 tags values of date as delivery date. And then we get rid of the filters on date. So a piece of code like this would compute the delivered amount if you format it correctly, but it's complex and worse because of this filter being placed by the formula engine that is going to be extremely slow. So that's not a solution that I would suggest anybody to use. On the other hand, what I strongly like is a model where you only have 1 day dimension. So we can just, I hate that, get rid of this, okay? I like to kill the delivery date dimension. And instead, if I have multiple dates, I just build multiple relationships all with date. This leaves the relationship inactive, but we can activate a relationship on demand. Now I have my year, I have the sales amount. If I want to compute my delivered amount, this code, of course, is no longer going to work because delivery date is no longer part of the model. But instead of this, I can use relationship and activate the relationship between sales delivery date and date, so that for the duration of this calculation of sales amount, the active relationship will be the one between delivery date and date. The difference in terms of performance is huge because use relationship is just metadata operation. It doesn't need to scan or produce any filter. And if I use the measure here, it produces the very same result, but this is going to work very quickly on any data model in a seamless way. And I can easily build sales amount, deliver amount, and purchase amount if I have it, or in the same report, slicing by the same table in a much better way. So this is not to say that the previous version was wrong. It was not. But it was a very specific solution for a very specific requirement. Besides, keep in mind that mostly users do not really want to do slicing by all the columns in the data dimension. If with this model that only contains 1 day dimension, here it is, we only have 1 day dimension, you still want to build a report like the previous one that contained the order year and the delivery year, with only the sales amount, you can easily do that, creating a new column in sales. If I go in sales and build a new column that I call delivery year, and I just write delivered in and then the year of the delivery date, that generates a column that contains a very small number of values, and it contains a description that slices by the year of delivery. So I can go in my report, take the delivery year column on the columns, and this is the same report that we were looking at before with just 1 day dimension. So you have 1 day dimension that filters all the dates in your model, and that makes the report simple to use. And if you need specific columns to build specific reports, you can just build them. It's quite simple, and the number of distinct values of this column is so small that performance-wise, this is not an issue at all. You don't have to worry at all about creating a column with 5 or 10 different values, even on a large fact table. Of course, you would probably create that in Power Query, but we like DAX and the model is small, so we just build it in DAX. Anyway, one thing that I forgot to tell you is that if you have any question at any point, you can just ask. Don't wait for me to stop because this is not going to happen. If you want to, if there's something that you're curious about, just start talking and interrupt me at any time, as all Italians do. So you know Italians, I guess. Anyway, so far, we just covered the modeling part. The best model, in my opinion, only contains 1 day dimension that filters everything with a set of relationships, some of which might be kept inactive. And you give the users the option to choose the relationship that is active. Besides, you can do that by using measures like I did here. in the code of delivered amount, I use relationship. If you are familiar with calculation groups, you can easily create a calculation group that activates the relationship on demand so that any measure can work with a different relationship being active, still having only one dimension in the entire model. So really the only scenario where you need 2 dimensions or 3, 4, 5 dimensions is when you want all of them in the same matrix. And you cannot solve it simply by creating a calculated column. If that is the case, then you end up building multiple data dimensions and you go ahead with that model. But the complexity is so much larger that I really strongly discourage you from doing that. Anyway, so far, we just created a data dimension. So let's say that we reach this point because we're here to talk about time intelligence. So the modeling part is just the first part. Once you have the proper model, then it's time to build calculations, the right set of calculations to compute values. Let's go for a simple year-to-date. I want to compute a new calculation that computes in January the value for January, in February the value for February, and so on. So January, February, March, April, I want a number that grows towards the end of the year, and then as soon as it reaches the next year, it resets and starts counting again. There are a ton of ways of obtaining the same result, from the simplest one that I'm going to very briefly show, that has the advantage of being simple, but it also has the disadvantage of being very rigid, not flexible at all. You cannot customize it because it's rigid. It's a simple solution that does not require any knowledge, but doesn't give you enough flexibility. If you want to compute the year-to-date of sales, you can just use total YTD. Total YTD of sales amount based on date. It's just a function call. You format the code the right way, then you place it here, and you obtain a year-to-date. You see that this number grows during the year by summing January 1st, then February, then March, and so on. And then at the beginning of the next year, it starts computing the values again. It starts again resetting. Despite working, it's not as flexible as you might want, because if you only need to compute a year-to-date, you have a function that does it. But what if I want to compute, for example, a running total? So I want to compute a number that grows, and instead of resetting in January, it goes on computing values by increasing the value all over time, so that at the end I have the total amount of sales over all time. There's no function that does it. And if you want to build such a calculation or any other calculation that is non-trivial, then using simple function like total YTD is not your best option. If you want to compute time intelligence, you need to understand a bit better how the evaluation contexts work. And the idea is when you are here, let's say in August, how do you compute the year-to-date? As humans, we intuitively think, well, you sum January plus February plus March plus April, and you just sum the values month by month. But from the DAX point of view, summing values month by month doesn't make a lot of sense. Whereas what it makes sense is to say, well, when you are here in August, you have a filter coming from the report that says you should only see August, and I want to change this filter. Instead of filtering only August, I generate a new filter that contains all the dates from the 1st of January of the current year up to the end of August. So I compute the end of August, then I compute the beginning of the year, and then I filter all the dates between the 1st of January and the end of the current period. I apply this new filter to the model, and then I compute whatever number comes out of it. And to do that, you need to write more code with the advantage of having a lot more flexibility. As I said, what we want to do is change the filter context, of the filter created by the report, with a new filter that contains all the dates between the beginning of the year and the current data, the last visible date. So we can start creating a variable, let's call it last visible date. and I can just compute the maximum of date. Whenever I write code that is non-trivial, I always start defining variable, and then I return the variables one by one, just to check that the numbers that I compute are actually correct. And by returning last visible date, now you see that my measure returns the 31st of January, the 28th of February, or the 30th of June. So for every month, I have the end of the current month. And that is the upper limit of the new filter that I want to apply. The second limit that I want is the 1st of January. Quick question for you. How do I compute the 1st January of the current year?
Yeah.
Louder than that?
I'm thinking, but I would do. We want this year, like current year, or we want year 2000.
Well, 2007, 2008, 2009. Now I don't know what I'm doing here. Okay, I messed up everything.
Year, not today.
Yes, I mean. Well, I can extract the year of the last visible date. And then I return that. And it returns 2007, then 2008, then 2009. And then how do I turn this into the 1st of January? I just use a date that has that year and then January 1st. So that returns the 1st of January of the current year. In 2008, it returns the 1st of January 2008. Finally, I can go for the result. I use calculate because I want to change the filter context. I compute the sales amount. And then I can use dates between. Dates between is the first time intelligence function that we are going to look at. It returns a set of dates. I need to provide the table, the column containing the dates, and then January 1st and the last visible date. This says on the filter context, replace any filter on the date with this new date, this new filter that contains all the dates between the 1st of January and the last visible date, and then compute the sales amount. The sales amount will be computed for each cell in a new filter that contains all the dates between the 1st of January and the end of the current period. Always need to format it. And if I format it as a decimal number, now you see it shows the year to date. And it's computing January, February, March, April, and so on. And then at the beginning of the year, it resets. So dates between is a simple function that solves the problem. But it is important not because dates between is so powerful. Dates between is a very basic function, and you will probably not use it a lot, but it gives you the idea of exactly how time intelligence works. In order to make a time intelligence work, you need to find the new set over which you want to perform the calculation, and then you use calculate to apply a filter. Now I use dates between, but actually dates between is a simple version of, not a simple, but is too powerful to compute a YTD. You can use dates YTD over date and get rid of all this stuff to just compute the sales amount with the YTD. Dates YTD does exactly what my previous code did. So it computes the last visible date. It searches for the 1st of January of the current year. It builds a set with all the dates from the beginning of January to the last visible date, and then performs the calculation. So dates YTD is the same in terms of performance as the code that we wrote before. It's just shorter, so it's good to use. And it shows you the generic pattern of time intelligence. It's always compute the new set of dates that you want to use, and then use calculate to change the filter context and compute whatever measure you have in the new filter context. Dates weighted is the first and the simplest function, but following the same pattern, you can use one of the many time intelligence calculation we have. So for example, you can compute the same period last year that are the sales in the previous year. And you just start with calculate because once you learn the pattern is always the same. And instead of using dates weighted, you use same period last year. What does same period last year do? Well, same period last year scans the current selection on data, so April, May, June 2007, defines the set of dates which are currently visible, and then moves them back 1 year. So that generates a new filter containing all the dates, but in the previous year. And if I use same period last year here, you see that it doesn't show anything in 2007 because there's nothing to show. But starting in January, it shows 101, that is the sales amount in 2007. So it's very easy to compute the sales in the previous year by using the pattern of computing, using calculate to move the filter context. Now, I would really love to obtain okay.
But one question, question about the implementation. You are telling that the longer code which you wrote is exactly the same as the shorter option. Is there a difference between performance, or it's just a kind of function on the top of the implementation which you use?
No, performance is absolutely the same, using same period last year, dates weighted, or any other time intelligence calculation. The complexity of this calculation depends on the time required to compute this filter. And this filter works on a table, the date dimension, that only contains, in this case, 1,000 rows. So it's neglectable. You don't even notice the time that is needed to compute that value. Therefore, all this version of the code, performance-wise, they are absolutely identical. There are no particular differences. It's just you use the most convenient way. But if you remember, we started with a different requirement because computing the year-to-date or the same period last year is simple. What if I want to compute a running total that starts from the beginning and goes towards the end? Well, for that, we do not have a time intelligence calculation, but we can easily compute a running total by following the same pattern we did before. So we search for the last visible date. That is just the maximum of date. And then we compute sales amount. And we just apply a filter where the date is less or equal than the last visible date. So this filter places a new filter over the date dimension over the date column, saying I want all the dates to be before the last visible date. The pattern is absolutely identical to what we have seen before. It's just a different type of filter. And if I place my running total formatted as a decimal number, you see that year-to-date resets on January 2008, whereas my running total just goes on and computes values one after the other. So it just works nicely, following the usual pattern, that is always use compute the set that you want. In this case, all what we needed is just the last visible date, and then apply the new filter. Then by combining together these functions, you can build more complex calculations. Because I have the sales amount, I have the same period last year. If you want to compute, for example, let's get rid of running total and year-to-date. The difference between January, the current year, and the previous year, maybe as a percentage, that's rather simple, and it's a regular calculation. So you can compute the growth as the sales amount minus the same period last year. That should be a decimal. You place it in the report, and that shows you at the beginning of the year. Of course, the same value of the sales amount, but then it shows you the difference between the current year and the previous year. And if you want to show it as a percentage, you just divide this value by the value in the previous year. Then you format it as a percentage, and that shows you that in January was 36.10% less than the value the same in the previous year. So Contoso is not really in good shape. You see that after 2007, nearly all the numbers are negative. We do have issues when we have one value but not the other. So we do not have sales here. We do have sales in the previous year. So this expression still computes a value and shows minus 100%, which is totally not sexy. So we probably need to add a condition like if there is sales, if there is some value for sales, then we perform the calculation. Otherwise, we blank it out, so that it shows the value for the current year. It shows no growth. And in a similar way, you might not be interested in showing also the sales in the previous year for August. That means in same period last year, you add a similar calculation, like if there are sales, then compute the value, otherwise blank it out. By doing that, you see that 2009 ends in July, and I do not even show data for August, September, October, and November, because it's not interesting to see data in the previous in the future, because that is just the future. It's things that are not happened yet. Moreover, you have the option of combining these measures together, these filters together. So, for example, let's get rid now of same period last year and growth. Let's go back to the YTD. Only find it, year-to-date sales. Here it is. I have the year-to-date. And in 2008, I might be interested in comparing the current year-to-date with the previous year-to-date. So the year-to-date of the previous year, because that generates charts which are very simple to read. If I look at the year-to-date sales of the current year and compare it with the year-to-date of the previous year, that gives you an idea of whether this year is better or worse than the previous year. If it is above, it's good. If it is below, it's bad. And it's a very simple chart that provides a lot of information. Now, year-to-date uses dates YTD. Same period last year uses same period last year. If you want to compute the previous year-to-date, you can simply create a new measure. Let's call it previous year-to-date, where you say, well, first compute the dates YTD. That returns a table containing the dates in the YTD, so all the dates between the 1st of January and the last visible date, and then you move that back 1 year. Same period last year will receive as input a table containing dates, and then it shifts back 1 year. Again, we format it in a decent way, and we place it here. And now you see that we have 2007 that starts with 101 and grows. Previous year-to-date does not contain anything. Whereas in 2008, we have 64, 125, and this is the previous year-to-date. That clearly shows that the previous year is always above the current year. So the current year is definitely a bad year for Contoso. But again, the important thing is not how to compute the previous year-to-date, but the fact that you can combine together time intelligence calculations in quite a simple way. You just call a function, and then on top of that, you use another function and another function. And by combining them in different ways, you can compute nearly any sort of time intelligence calculation. It's always a matter of finding where you are in the current filter context and how the data needs to be moved back. Finally, same period last year is nothing but syntax sugar, a simplified version of another function that is dateadd. Let me show you dateadd very quickly. Did I click on new measure? Yes. Let's say that I want to compute the sales in the previous quarter. There's no previous quarter function. There is no way to obtain. There's no same period previous quarter, but you can use date add, which is a more generic function. So you can use calculate again, compute the sales amount, and then you can use date add. Date add doesn't do what its name suggests, that is adding dates. It's a time shifter. You pass to it a table containing dates, and then this shifts back or forward this set of dates. So we start with date, and then we can go back, and you can go back 1 day, 1 month, 1 quarter, or 1 year. So if you want to go back 1 quarter, and then you compute this as a decimal number and place it in the report. Let's expand 2007. You see that for the first quarter, it shows a blank. And then in April, it shows the data of January. In May, it shows the data of February. In June, it shows the data of March, and so on. So it shows the same data, but in the previous quarter, which is the same as doing, instead of -1 quarter, you can do -3 months. That will be absolutely the same calculation, but you can use -2 months if that makes any sense to you. So you can use date add to move data back and forth. And please note that the engine is smart enough to actually understand the unit of measure that you are using. In March, we have 31 days, and we are showing the data of February that only contain 28 days. And in April, we are showing the data of March, even though the number of dates in the different months is different. All these functions are smart enough to understand the unit of measure. And the unit of measure they understand are day, month, quarter, and year. So they can understand whether you have selected 1 day, 1 month, 1 quarter, or 1 year. They cannot understand, for example, weeks. If you need to do calculation over weeks, then you cannot use this time intelligence calculation. You need to go to a more complex piece of code. That is, you write your filter conditions by yourself without relying on time intelligence calculations. Just because there's no way that there are no predefined functions that compute over weeks. So by combining different time intelligence calculation, you can easily compute any sort of calculation. I just want to show you one last example because before we finish, for something that looks complex, but it's rather really simple to compute. Let's get rid of everything from here and just leave sales amount. And instead of slicing by year and month, we slice by individual dates. And then we build a chart out of it. You see, the chart is not easy to read. Actually, it's pretty crappy because it's showing a very strong variation over time. So you cannot actually understand whether things are going bad or worse or good, and you cannot derive any insights from that. In such a scenario, it's very common to create a calculation that computes a moving average. So for example, you can compute a moving average over 6 months in order to compute the average sales amount per day, but over the last 6 months, so that you obtain a much smoother chart. And computing it is exactly using the same pattern as any other time intelligence calculation. You can just build a new measure. Let's call it moving average. That uses calculate, sales amount, and then you need to use a days in period. You need to provide the date table. So you want all the dates that are in a given period. That's what days in period does. So you want the data as the first column is the reference to the date. Then you need to provide the start date. As we did for the year to date, we start from the end of the current period, that is the maximum day data. If you have selected a quarter or a month, it will be the end of the month. If, as in this case, you only select 1 day, then max data returns the current date. And then you go back, for example, -6 months. Let's go for 3 months, otherwise it's too smooth. So you see the pattern is always the same. Calculate, whatever measure you want to compute, and then a time intelligence function that defines the set of days over which you want to perform the calculation. This computes the sales amount. So that computes the total sales amount in the entire period. And if I place this in the report, it's not really cool because it shows behavior, but you see that the value is much larger than the value of the sales amount. You cannot compare one with the other because actually I'm not computing a moving average, I'm computing a moving total. If I want to compute a moving average, I need to divide this by the number of days. And that provides a much smoother line. At the beginning, it doesn't show, it starts very high and then goes down because, well, no, because we actually have a lot of sales. And then you see that you can derive some knowledge from this line because this is actually showing you a behavior. We have a drop of sales here, which was not totally not evident before because we have all these peaks. And we have a drop and then the sales went down and then went up, down again. And here at the end, we have this bad effect that we show a moving average that slowly go down. So as usual, we need to protect this code saying, well, if there are no sales, if there are sales, then compute the value, otherwise blank it out. So we no longer have the problem at the end of having that line that goes down for no particular reason. And the moving average is quite fast because, again, that requires only computing the days in period. That days in period is very fast because it only scans a table with 1,000 rows and moves it back 3 months. If you want 3 months, that's the way you go. If you want only 1 month, then you obtain a line that is less smooth, but still provides some insight because that is a moving average over 30 months. If you want 15 days, then you go minus back 15 days. You have again another line that is even less smooth, but still provides a lot more information than just a line dropped in a chart that shows values which are impossible to read and do not provide good insights to anybody. Okay, I ate all my time by running through these demos, so I don't want to spend more time about that. But if you have any question or anything that you are interested in talking about, I'm here, so let's just talk.
Guys, any questions?
Provided that you're still awake. I'm not sure about that.
Yeah. So it looks like no question. There's no more question.
Okay.
But nevertheless, thank you for the session.
Thank you, guys.
It was an honor that you decided to prepare something for us.
No problem at all. It was a pleasure for me.
So thank you.
Then spend the rest of the evening the best way and enjoy DAX.
Yeah, thank you. Thank you.